So today let us see Rutherford's nuclear model of atom. So it is explained by alpha particle scattering experiment. So here he used radioactive source which produces high energy stream of alpha particles. So first these alpha particles, when they are emitted from this radioactive source, they first strike onto this lead plate. So here he will be using, Rutherford is using lead plate only to prevent the scattering of alpha particles. So whenever these alpha particles they come with a high energy, they usually scatter. So in order to prevent that, he used a lead plate over here which increases its focus onto this gold foil. So now alpha particles, they travel and they strike at this point on the gold foil. So when they strike here, most of them they showed zero deflection, that is they were undeflected. They have directly struck this point, and as we know this is a fluorescent screen, zinc sulfide screen. Whenever alpha particle they fall onto the screen, they show a bright spot. So if when they show deflections, even at these positions they even show a bright spot. So now these deflections are shown by very few alpha particles by very less angle of deflection, and here this deflection is shown by either one or two alpha particles which they directly strike onto the positively charged position and might show direct 180-degree deflection. So now here they have showed zero deflections, most of them. Few of them they have showed very less deflection, and very few of them they have showed 180-degree deflection, or we can even say back scattering. So now based on this experiment, based on these observations, he concluded that atom is spherical, it is electrically neutral, and then as we can see, most of the alpha particles they have scattered, they have passed the gold foil without any deflections. So most of the space inside atom is empty, and then as very few particles they have showed deflections. So we need to conclude that these alpha particles they are positively charged. As we know that like charges repel and unlike charges attract, this positively charged particle, when it goes near to any kind of positively charged center, only then it shows deflection. So majority of them they have showed zero deflections, few of them they have showed minute deflections. So what he concluded that the positively charged center in atom is concentrated at any one point in the atom. So he said that positive charge is concentrated at center of atom. He named that region as nucleus. Nucleus contains both protons as well as neutrons. So the sixth point is mass of atom. Mass of atom is concentrated at center. So here you can see he used only gold foil. Why he used only gold foil? Because gold foil has a property, it is having a property called malleability. It shows a property called malleability, which means malleability is we can make gold into thin sheets. very thin sheets, into very thin sheets. So here only by using very thin sheets we can pass these alpha particles. If we use thick sheets like aluminium or silver, the passage of alpha particle will be difficult, and he couldn't find any observations. And the second property is high atomic number, which is 79. Because of high atomic number, the charge in nucleus is very high positive charge. Because of this very high positive charge, the repulsive force of nucleus on the alpha particle is very high. What if it is in case of aluminium? So when we consider aluminium whose atomic number is 13, its nucleus is very small, positive charge is small, as positive charge is also small, then repulsive forces are obviously will be small. Very less repulsive forces in case of aluminium. Same is the case with silver. He then concluded that nucleus is surrounded by electrons. Nucleus is surrounded by electrons. Here we have electrons over here around the nucleus. So this nucleus and electrons, they are held together by two forces, centripetal force and centrifugal force. The centripetal force is towards the nucleus, that is, this force is on the electron towards the nucleus. The centrifugal force is the opposing force present between nucleus as well as the electron. So now let us look into the drawbacks. Okay, so first, Maxwell, he proposed a theory, electromagnetic theory. So according to him, when a small charged particle, this is a small charged particle, electrons are very small. When a small charged particle, when they revolve around the oppositely charged center, they lose their energy continuously. So when this electron, they lose their energy continuously, they directly fall into the nucleus. But in Rutherford's experiment, we couldn't see such observations. So what he said, what was his first drawback? His first drawback is failed to explain the stability of atom. And in second point, he even failed to explain the arrangement of electrons around the nucleus. Why? Because he only explained about the concentration of mass of the atom. Mass of atom is concentrated at the center. Yeah, here you can add even one point, which is mass of atom is concentrated at the center. Mass of atom is concentrated. Yeah, we have wrote it already, okay. No need to write, okay. We have already written that point. So now, it failed to explain the stability of atom, couldn't explain the arrangement of electrons around the nucleus, third point is it couldn't explain the line spectrum of hydrogen atom and discontinuous spectrum. So, so this is Rutherford's nuclear model of atom.